Hey friend, have you ever come across a coding challenge that asks you to set matrix zeros? It's pretty nifty, and I figured I could spill the beans on this little gem in Python, keeping things casual as if we're just chatting over coffee. So, the set matrix zeros problem goes like this. You have this mxn matrix, right? And if any element in a given row or column turns 0, the whole row or column gets blanked out, meaning all other elements become 0 too. Python's dynamic handling of matrices makes this a cool little showdown against inefficient solutions. Imagine you are given something like 0 appears in the second row, second column, so we nix that row and column. Early attempts might just loop through the matrix, check if a number's 0, then clear an entity if it is. The thing with this naive approach is when you zero a row, you still have to scan the whole row, which feels redundant, doesn't it? Now, imagine being told to keep track of which rows and columns to zero with just one pass over the matrix. Sounds daunting at first, but Python's flexibility comes into play smoothly here, especially when it's all about using just one loop, avoiding that need for extra space or unnecessary complexity. Let's break it down, shall we? As we stroll through the matrix from top to bottom, left to right in this one-loop affair, we mark any rows or columns with zeros using sets for rows and columns. In the Python world, a set stores only unique items, ensuring we are keeping tabs on rows and columns effectively. We initialize an empty set for rows and columns, then as we encounter zeros, the matrix elements need to know if they should become 0 too. We do this by iterating once with a double loop. On the outer loop, we go down the rows, and the inner loop zips through each element in that row. When the 0 insight comes, we mark the row in the row_indices_2_0 set and the column in the column_indices_2_0 set. Python makes this simple and snappy. After we've flagged our rows and columns with the zeros, here comes the cleanup time. We iterate again, and wherever we find an element at index k in a row that contains a 0, we are setting it to 0. That's the beauty of Python. It feels almost too convenient, almost too neat, especially for someone who's just diving into coding. For optimizing, the goal is to minimize our steps without using extra space for storage like another matrix, using only set-based flags for rows and columns. We are trying to keep our data structure lean, which, admittedly, is a pretty neat trick in Python's arsenal, right? Let's test it out with some code. I'd have to share it directly, but here's the thought process. We keep an eye on the original matrix using lists of lists and keep a tight loop for our single pass. After that, a second loop fixes up our matrix, but this time, it uses sets to know what's up with the zeroed out rows and columns. I'm telling you, working with sets to remember our zeros feels like playing a game of memory, but with elements and positions instead of cards. But it's efficient in memory usage and fast in execution. When we are done, we are left with the cleaned up matrix, only with rows and columns containing zeros fully replaced with zeros, and the rest still holding on to their values. And to finish, here's something for you, my friend. For a more in-depth look at this and similar challenges, keep in mind you can always visit neeraj.qzz.io and subscribe to TechLab. There you'll find a treasure trove of coding tutorials and problems to sink your teeth into with your freshly sharpened Python skills. Now, let's get coding and keep this conversation alive as we tinker with more algorithmic puzzles in the future, shall we?